In section 10.1, we discussed the conic section called the ellipse. And this is kind of a squished circle, if you want to say. It does have some similar characteristics to the circle in that it has a center and then you go out a certain amount from the center. But in the circle, you would go out the same amount in every direction. In the ellipse, that is not the case. So I want to take a look at two ellipses to kind of start our discussion. And our instructions say to sketch the graph of each by locating its x-intercepts and y-intercepts. So what I've done is I have done just that. For the first one, I actually worked it out. And just a reminder, when you're looking for the x-intercepts of something, you let y equal 0. You'll notice that we simplify and solve and we end up with x is equal to positive 3 and negative 3. So we have an x-intercept here at positive 3 and one here at negative 3. Notice that the center is at 0, 0. Here we had to find the y-intercept, so we let x equal 0. Similarly, we solve and we get y is equal to positive or negative 5. So we have 5 and negative 5. So we want to kind of be drawing some conclusions as we look at this. We see the equation, we see the ellipse. I didn't show the work for this one, but it is exactly the same process. To find the x-intercept, you let y equal 0, and you end up with x is equal to positive 4 and negative 4. So we have negative 4, we have positive 4, again noticing that our center is appearing to be at 0, 0. And then for the y-intercept, we let x be 0. Solving for y, we get positive or negative 1. We go through the y-axis at 1 and the y-axis at negative 1. So I hope that you are noticing, and these are special cases because they are centered at the origin. Whatever the square root of this number is on the bottom of the x, that tells us how much to go right and left from the center. Now, since the center was at 0, 0, we go, we're at negative 3 and positive 3. But I want you to think more in terms of going to the left 3, 1, 2, 3, and to the right 3, 1, 2, 3, from the center, wherever it may be. It just happens to be at 0, 0 here. Then we have, on the bottom of the y term, a 25. When we think of y as up and down, it certainly works that way with our axis. And we go up 1, 2, 3, 4, 5, down 1, 2, 3, 4, 5. So our denominator is going to tell us how far away to go from the center. And we do that by taking the square root of the denominator. Similarly, square root of 16, we went to the left 4 and to the right 4. There's nothing under the y, but there is, it's just an understood 1. Square root of 1 is 1, so we go up 1, down 1. Using that same thought process, let's see what we can come up with for this ellipse. Well, we see these square root numbers on the bottom, so we see the square root of 16 is 4. It's under the x term, so we're going to go to the right and to the left 4 units from the center. Under the y term, we see 25. If we take the square root of that, we get 5. So that means we're going to go up and down 5. But from where? Well, notice how much this resembles the circle. And it follows the same HK-ness that the circle does. The center of this ellipse is at 2, 1. So we'll start by marking our center at 2, 1. Then we're going to go from the center to the right and left 4. 1, 2, 3, 4. 1, 2, 3, 4. From the center, we are going to go up and down 5. 1, 2, 3, 4, 5. Almost ran out of room. 1, 2, 3, 4, 5. And then we are able to sketch in our ellipse. It's kind of interesting that the circle certainly helps build the ellipse. Oh, it could be one of my worst. But it's not actually a point on the ellipse. Here's the equation of an ellipse in standard form. Please do note that where you have M and N on your notes, you want to change those to A and B. So we have this form. It's always going to be equal to 1 when we are in standard form. Notice how the numerator is very circle looking, x minus h quantity squared and y minus k quantity squared. The denominator of the x term is going to be named a squared. The denominator of the b term is going to be named b squared, or the y term, sorry, it's going to be named b squared. So if a is not equal to b, then the equation represents an ellipse. If a is equal to b, it's actually a circle because you're going the same amount out horizontally that you are vertically. The center will be at HK. The absolute value of a, so we take the square root of this, gives the horizontal distance from the center of the graph to the ellipse. The absolute value of b gives the vertical distance from the center of the graph or center of the ellipse to the ellipse itself. Let's practice this on this equation of an ellipse. So first we will want to identify what is the center, because this is how we count, or where we count from. So the center of this particular ellipse is going to be at -3, 0. So we'll go ahead and locate that point here. Then the next thing that we want to consider is how far out do we go horizontally. Now, you could do vertical first, certainly that would be fine. But we look under our x term and we see a 4. We take the square root of 4 and we get 2. So from the center, we will go to the right 2 steps and to the left 2 steps. We will now consider how far to go out vertically. We look at the term underneath the y squared term, and that's 20. The square root of 20 is 2 times the square root of 5. Now, when we are going to sketch this graph, we would like to have a decimal approximation for that. So that's going to be about 4 and a little bit more, maybe 4.3 or 4.4. So I'm going to go up 1, 2, 3, 4, 1, 2, 3, 4, and a little bit more. And down 1, 2, 3, 4, and a little bit more. And we're ready to sketch in our ellipse. And aren't we glad that it says sketch?